Exploring angle pairs. Adjacent angles are two angles that share a common vertex and side, but have no common interior points. So in each of these diagrams, I want you to determine whether each of the following pairs are adjacent angles and support your answer. So go ahead and press pause, draw these diagrams, and determine whether they are adjacent angles or not based on the definition given. Check back with me and see if you got it right. Now let's talk about it. Number 1 and 2, those angles are adjacent angles because they fulfill all the parts of the definition. They have a common vertex, they share a side, and none of their interior points are the same. So all the points inside angle 1 are different from the points inside angle 2. None of them overlap. Number 2, this falls apart at the common vertex rule. They have two different vertices for the angles, so those are not adjacent angles. Angles 5 and 6 also fall apart in the same place. They have different vertices and therefore are not adjacent angles. Angles 7 and 8 do satisfy all the parts of the definition: common vertex, share a side, and no common interior points, so these are adjacent angles. Angle 9 and 10, you need to be careful with this. This arc marking. Now don't be fooled in thinking that this is a congruent marking. If it is one all the way across, that's talking about the big angle, and that's referencing angle 10. When you see congruent arc markings on adjacent angles, you're going to see them slightly offset, so you can tell the difference between congruent angles versus when the arc marking is talking about the whole angle. So when we talk about angle 9 and angle 10, they do have a common vertex. They do share this side. However, all those points inside of angle 9 are also inside of angle 10. So since they have common interior points, angle 9 and 10 are not adjacent angles. Vertical angles are two angles whose sides form two pairs of opposite rays. So if you look at this first set, we talked about opposite rays before, and those are two rays that go in complete opposite directions with a common initial point, so it's actually a line. So we have vertical angles when you have two lines that intersect each other, and they're the ones that are opposite from each other. So in this first diagram, angle 1 and 3 are vertical angles. And angle 2 and 4, those are vertical angles. So I want you to pause, take a look at the next two diagrams, and list all of the vertical angle pairs that you see. Then check back with me and see how you did. Hopefully for the second set, you got angle 9 and angle 7. So angle 9 and angle 7, these are the only ones that actually have two lines that are intersecting each other. So 9 and 7 are the only vertical angles. Here, it kind of looks like you have a lot of pairs of vertical angles at first, but when you look at the only opposite rays, you have one here and you have one here. This one is not an opposite ray because, as you can tell, this does not make a straight line with that one. So we don't want to focus on that one. We just want to focus on the actual opposite rays that we have. And then when you look here, you have angle 13 and angle 10 are vertical angles. So even though it might look like there are a lot, you have to be really careful to make sure you're finding opposite rays. Now, the other thing you need to remember is that vertical angles are always congruent. Remember, congruent means that the measures are the same. So if we look at these vertical angle pairs, angle 1 and angle 3, those actually have the same measure. So do 2 and 4, 9 and 7, and 10 and 13. Now, taking what we know about vertical angles, we want to find the value of the variable. So this very first one, we have the two intersecting lines, and we have these vertical angles, the ones opposite from each other. And we just learned that vertical angles are congruent. So that means the angle measured 110 is exactly the same as the angle measured 2x plus 40. So we just need to find the value of x. So we subtract 40 and then we get 70 is equal to 2x, and then we want to divide by 2 to isolate the variable, and then we get 35 is equal to x. So that's our answer. Now, go ahead and pause, try the second problem on your own, and check back with me to see if you got it right. Hopefully you set x equal to 5x minus 48, and when you solved, you got an answer of x equals 12. Now, if you wanted to double check your answers to make sure you did the algebra correctly, you can always just take the value of x, substitute it back into both angles, and then make sure that this angle is exactly the same measure as that one. Next, we want to talk about complementary angles versus supplementary angles. Now, you should have learned what these were before, so this should be just a little review. But complementary angles are two angles whose sum of their measures is 90 degrees. So you have two angles that add up to equal 90 degrees. Supplementary angles are two angles that add up to make 180 degrees. So we have these different pairs of angles down here, so we just want to sort them. These purple ones, this one is 120 degrees, that one's 60. When you add 120 plus 60, you get 180. So these are an example of supplementary angles. Now these blue ones, this one's 40 and this one's 50. When you add those, you get 90. So this is an example of complementary angles. Now, these two diagrams do not have any angle measures. However, there are other things that can help us determine whether they're complementary or supplementary. Here, we talked about an angle earlier that has this box. That box tells us that this is a right angle. Right angles are 90 degrees. So since you have these two adjacent angles that together make 90 degrees, these are complementary angles. Be familiar with this diagram, you will see it often. And here you have this other diagram, two adjacent angles. Now we have a straight line. Now we learned that a straight line is also called a straight angle and is 180 degrees. So even though we don't know the measure, we know this angle plus that one makes 180 degrees. So these are supplementary angles. Next, we want to find the supplement and complement of each given angle measure. So what this means is you want to find the angle measure that will be supplementary to this one and the angle measure that will be complementary to this one. So in order to do that, we're just going to take, for the supplement, it needs to be 180, and if we subtract the angle that we have, we should get the other angle, which is 152. So 152 degrees is called the supplement to 28 degrees. Next, in order to find the complement, complementary angles add up to 90, so we take 90, subtract the angle that we're given, and then the other angle is going to be 62. So the complement of 28 degrees is going to be 62 degrees. Now, I want you to go ahead and pause, try these next two, and check back with me and see what you get. They are a little different than this example, but I just want you to follow this model. So for the second one, I gave you the measure of angle B as x. Now when you take 180 minus x or 90 minus x, you don't actually get an angle. So our answer is just going to be an expression. So the supplement of angle x is 180 minus x. You want to put that in parentheses so that this degree symbol tells you that this whole expression is the supplement. Likewise, for the complement, you have 90 minus x in parentheses with the degree symbol. On this last example, the supplement should have been easy. 180 minus 176 gives you 4 degrees. Now for the complement, 90 minus 176 equals negative 86. Now, this year in geometry, we are not going to be talking about negative angle measures. We're only going to work with positive angle measures. And so this angle of 176 does not have a complement. So we just say NA, not applicable, or you could put none or does not exist. Next, let's talk about a linear pair. A linear pair is referred to as two adjacent angles whose non-common sides are opposite rays. So we've already defined adjacent angles, common vertex, common side, and no common interior points. Now the extra special part is that the non-common sides are opposite rays. So the other side of angle 1 and the other side of angle 2, they make opposite rays, which means a straight line. So here we have angle 1 and angle 2 are linear pairs. So go ahead and pause, try to find all the linear pairs in the second and third diagram, and then check back with me to see if you got them right. So hopefully for example 2, you got angle 3 and 4, angle 4 and 5, angle 5 and 6, and angle 6 and 3 for the linear pairs. Now in this diagram, we have angles 7 and 8, which are along this line. Now I need you to be careful, because you might think that angle 9, 10, and 11 are also a linear pair. However, that word pair implies two. So you don't ever want to talk about three angles being a pair. That doesn't really make sense. So it's just the two angles on this side that are a linear pair. Likewise, we have angle 9 and 8 making a linear pair, and we do not include 10, 11, and 7. Okay? Now the other thing we need to note is that linear pairs are always supplementary. So every linear pair is going to add up to 180 degrees. Angle 1 plus 2 is 180, 3 and 4, 4 and 5, so on and so forth. So now we want to work through these two examples and find the value of the variable. So we need to take what we've learned about linear pairs, about them being supplementary, to find the value of the angles. So these two angles are a linear pair, and they're supplementary. So 75 plus 2x minus 5, they're going to equal 180. So first we want to combine like terms. We have 2x, 75 minus 5 is 70. That equals 180. Subtract 70 from both sides. And then we get 2x is equal to 110. Divide by 2 to isolate the variable, and we get x is equal to 55. Now, don't put the degree symbol just because we're talking about angles here. You need to remember x, in this expression, x is just a number. It's when you plug it in and you find the entire angle measured, that's when you find, that's when you're going to put the degree symbol for your answer. So here, no degree symbol, our answer is just x equals 55. Go ahead and pause, work out the second one, and check back with me when you're finished. Hopefully, when you set up your equation and solved, you found that x equals 31. If you didn't get 31, pause, check your work with mine, and see where you might have made a mistake. Next, we're going to talk about an angle bisector. Remember, we talked about that word to bisect. It means to cut exactly in half by two pieces. So an angle bisector is a ray that divides an angle into two adjacent angles that are congruent. So here we have the whole angle RST, and then we have this ray SP that cuts the angle into two congruent parts. Now this I mentioned before. When we're talking about congruent angles that are adjacent, they're going to be offset. Those arcs are going to be slightly offset so that you know that we're not talking about the whole angle and it's not just one arc across. So make sure you are paying close attention to these small details. So the question is, what is the angle bisector of angle RST? So what is bisecting that angle? And it's ray SP starting at S, going forever in the direction of P. That is the ray that's bisecting angle RST. Now, we're going to fill in the blank here. Angle blank is congruent to angle blank. So that bisector cuts us into two congruent angles. So the first one, angle RSP, is congruent to angle PST. Now, again, Let me highlight when we first talked about how to name angles. We said you can use the vertex if there is only one angle at that vertex. But here we have angle RST, the big one, angle RSP, and angle PST. All of them share vertex S. So because we have three different angles at vertex S, you cannot use the letter S to name any of those angles. You're going to have to use three letters to be specific. Here it tells us that PT is the angle bisector of angle RPS. Find the two angle measures not given in the diagram. So here in this very first one, we have angle RPS, and we know it's bisected by PT. So that means that this angle is going to be congruent to this one. So I'm just going to go ahead and make my markings. Now if they're congruent, that means this angle is exactly the same. So this angle is also going to be 39 degrees. So now I found the measure of angle TPS equals 39 degrees. Now the last angle I need to find is that big one, the measure of angle RPS. And we're just going to take 39 plus 39, and that's going to give us 78 degrees. Okay. Go ahead and pause, try the second one, pay close attention to the notation, and check back with me when you're finished. Hopefully you noticed the fact that this is one continuous arc all the way across. So that's telling us that angle SPR, the big one, is 98 degrees. So if that big one is going to be bisected by PT, that means we just need to cut it in half. So we divide it by 2 and we get 49. Then we have the measure of angle SPT equals 49, and the measure of angle RPT equals 49. Now if you wrote your two angles differently, you could have written this as the measure of angle TPS in the opposite order, or angle TPR in the opposite order. But remember, the vertex P has to stay in the middle. Here's another example that we can work out regarding angle bisectors, except this time we're given two expressions. So I want you to go ahead, pause, find the value of x, and check back with me to see if you got it right. Because BT bisects the angle, you should have known that these two are going to be congruent to each other. So this angle is congruent to this one. So if they're congruent, that means their measures are the same, so you can set them equal to each other. Then, when you solve, you should have gotten x equals 10. Now, way to double check your answer again is just to take x equals 10, substitute that into both expressions, and make sure that angle ABT is the same measure as angle TBC. Now let's take a look at this example. This one is different just because it doesn't give us a diagram, so it's just a little bit more work on our part. It says ray BD is the angle bisector of angle ABC. So first, let's draw our diagram. Remember, you should get in the habit of it. Whenever you don't have a diagram given, you always want to make sure you draw one for yourself first. ABC, and then BD, so we have some point D out here, and this is bisected. So I just want to put those markings just so I know, and I can remind myself that it is bisected. It says given the measure of angle ABC, so ABC, that means the whole angle here is 110 degrees. Find the measure of the other two angles. So I just want to take the whole angle, bisect it, we'll divide it by 2, and we get 55. So the measure of angle ABD equals 55 degrees, and we have the measure of angle DBC equals 55 degrees. And there's our answer. For this next one, try this on your own, pause, and then come back when you're finished and check your answer with me. So hopefully your diagram looks similar to mine, and then you set the two angles equal to each other, solved and found x equals 2. Then, if you want to double check to make sure you got it right, substitute the 2 back in for x in both expressions, and we should have gotten them to be the same. They're both 14, which means we did it right. So then you can just add 14 and 14 to get 28. That's it for today. Make sure to submit your questions on the website if you had any while you were watching the notes.